In this worked example, we're looking at a cathode ray oscilloscope question, and it says that a cathode ray oscilloscope is used to display a wave of frequency 5 kilohertz. The display is shown. As soon as I know that the frequency is 5, and then kilo means 1,000, so 5,000 hertz, I want to calculate the time period. So 1 over the frequency is the time period. So what is 1 over 5,000? If you know, leave it down in the comments below. 2 times 10 to the negative 4 seconds is the time period there. So my job is to figure out how much time each one of these centimeters represents the time-based setting of the CRO. So we've got 1 centimeter and 2 centimeters is the entire waveform. And I know that that's also the time of an entire wave. So we can kind of, use that language to see what's going to cancel here. We could say 1 wave per 2 centimeters. And from this information, we could say 2 times 10 to the negative 4 seconds per wave. Right? So that's the time period of the wave. And if we multiply it by, the number of waves per division or per centimeter in this case, now we're getting waves to cancel, and we've got the amount of time per centimeter, which agrees with the units of the answer choices. So 2 times 10 to the negative 4 divided by 2 gives me 1 times 10 to the negative 4 seconds per centimeter. So if that were an answer choice, I would select it because it's correct, but it's not. Everything is in either microseconds or milliseconds, and so you'll have to convert into those units to compare. With a nice round number like this, it's also possible to just sort of read off like, oh, if the whole thing is 2 by 10 to the negative 4, then each square is 1 by 10 to the negative 4. But here's sort of a more formal way to sort of approach that calculation. All right, if we multiply this and convert it into milliseconds, that there's 1,000 milliseconds per second, we'll multiply those two and we'll get 0.1 milliseconds, because we cancel out seconds, per centimeter, which also is not an answer choice. You can see the two values in milliseconds are 10 and 100, not 0.1. So those aren't correct. It's got to be one of these two here. So let me convert the time-based setting again. The correct time-based setting is 1 by 10 to the negative 4 seconds per centimeter. Now we'll convert to microseconds. There is 1,000,000 or 10 to the 6 microseconds per second. So when you multiply 10 to the negative 4 by 10 to the positive 6, you get 10 to the 2 or 100. So 100 microseconds per centimeter. So each square represents rather 100 microseconds of time. This has been a cathode ray oscilloscope or CRO question with Dr. Schleif, and we'll see you next time.